Good morning, all. Today we are going to start a new topic in the vehicle characteristic, name is the braking characteristic. Okay. So, in the previous lecture, we were discussing about the different types of the slow speed turn, high speed turn, and super elevation, and different facility or and the design vehicle specification. Okay. So, in the previous lecture, we were discussing about the braking characteristic of a particular vehicle. Another critical characteristic of a vehicle is the ability to stop once the brakes have been to be engaged. Again, basic physics relationships are used. The distance traveled during a stop is the average speed during the stop multiplied by the time taken to the stop. So the equation known as dv is equal to s by 2 into s by a is equal to s square by 2a. So where the s is the initial speed and a is the acceleration rate. So what is the acceleration rate? Acceleration rate is that when a driver apply a brake to the particular vehicle at a particular speed, the time taken by the vehicle to stop at that particular location, it's called the deceleration rate. So the equation in dv is equal to s square upon 2a. So the dv is the braking distance. So the braking distance or the braking characteristic are used in the side distance or SSD or as well as the OSD. So SSD is the stopping side distance and OSD is the overtaking side distance. So in the convenient, how to express speed in the mile per hour are dv is equal to 1.075 s square upon 8, where s is the speed. Note that the 1.075 factor is derived from the more exact conversion factor to be mile per hour to feet per second. So, to express this equation in terms of the coefficient of forward rolling or skidding friction, where F is equal to dv is equal to s square upon 30f. So, what is the skidding? What is the skidding or skidding friction? So, skidding is when a vehicle moving at a particular speed at a curvature, the when the driver start a movement of the front vehicle, the rear vehicle will not follow that particular path, but just take some kind of a drag in the turning movement. So the phenomena or the distance which are transferred from the origin path to the off-braking path is known as the speed. So when the braking characteristic or the braking speed, uh, braking distance in terms of the skidding friction is known as a dv is equal to s square upon 30f, where f is the coefficient of forward loading slugging friction. When the effect of the grades are considered and the braking cycle leading to reduced speed other than zero are considered, equation dv is equal to si square minus sf square upon 30f plus or minus 0.01 g. So where g is the grade. So when a vehicle moving at the downgrade of the particular and we are discussing about not making a speed of a zero, but something more than that. The braking distance equation is known as is formulated dv is equal to si square minus sf square upon 30f plus or minus 0.01 g. When there is an upgrade, plus is used and minus is when using a downgrade. This results in the shorter braking distance on upgrade, where gravity helps the acceleration, and the longer braking distance on the downgrade, where the gravity is causing acceleration. Okay, for that particular equation, for a holistic equation, the braking distance equation termed as a d is equal to si square minus sf square upon 30 0.348 plus or minus 0.01 g. Okay, the braking distance formula is also a favorite tool of accident investigators. It can be used to estimate the initial speed of a vehicle using measured speed marks and an estimated final speed based on the damage assessment. In such cases, actual estimator values of F are used rather than the standard design values provided by the ASTO. So, while taking accident analysis or accident assessment, braking distance equation termed as ED is equal to 75 minus SI square minus 202 upon 30 0.25. But this is not the kind of equation which are used in the examination purposes. So when an accident analysis are going to take place, this kind of the braking distance or the speeding effect are taken into account. Okay. The next is total stopping distance and its application. So, when the stopping distance, so what is called the stopping distance? Okay, so when a driver moving a vehicle at a particular speed on the road mark and with the help of the vision and hearing characteristic, the driver note that there are some kind of the obstruction are available in the forward area. So when the driver are applied a particular brake and the vehicle are the stop moving that particular location, the distance between when the driver applies the brake and the vehicle actually stop. The particular distance is known as the stopping distance. The total distance to bring a vehicle to a full stop from the time to needed to do so is first noted. It is sum of the reaction time PR and the braking distance dB. Okay, so the equation is V is equal to 1.47 SI into T plus SI square minus SS square upon 30 0.348 plus or minus 0.01 G. So stopping distance is nothing but when it is required to apply braking at the first position to the particular stretch where vehicle are actually stopped. The total distance are called the total stopping distance. Okay, the concept of the total stopping distance is critical to many applications in the traffic engineering. Three of the more important applications are discussed. The first is the safe stopping side distance. One of the most fundamental principles of a highway design is that the driver must be able to see far enough to avoid a potential hazard or collision. Thus, on the roadway section, the driver must have a side distance that is least equivalent to the total stopping distance required at the design speed. So, safe stopping side distance are depend on the design vehicle as well as the design speed. So, in the previous lecture, we will discuss what is a design vehicle. So, design vehicle is that a particular class of the vehicle which are taken into account while the designing of a highway, while the designing of a new highway as well as the improvement of the existing highway. But what is a design speed? Design speed is that a kind of a speed limit that all the vehicle or it is a maximum speed which all the vehicles are traveling in the frequent manner. So it is called the design speed. So when we are talking about the national highway, the design speed for the passenger car is 100 kilometer per hour, and for the truck it is 80 kilometer per hour. So this kind of the speed regulation or the speed signage or the facility of the speed studies are known as the design speed. So different classification of the roadways or different classification of highways has a different design speed. So stopping side distance are related on the design speed as well as the design vehicle. The stopping side distance is that providing kind of a side distance to the driver so that it can stop a vehicle without any collision at the design speed. Essentially, this requirement addresses the critical concern driver rounding a horizontal curve and negotiating a vertical curve is confronted with the downfield or overturned track or some other situation that completely blocks the roadway. alternative for avoiding a collision is to stop. The design must be such that every point along its length, the driver has a clear line of vision for at least one full stopping distance. By ensuring this, the driver can never be confronted with the need to stop without having a sufficient distance to do so. The stopping side distance is that providing that kind of the facilities, which providing that kind of a facility that the driver are stop the vehicle at a certain distance without a collision or without a hazard situation. Okay, the next is a decision side distance. While every point in the section of a highway must be designed to provide a least safe stopping side distance, there are some sections that should provide a greater side distance to allow driver to react to potentially more complex situation than the simple stop. Okay, the side distance based upon the pre-collision avoidance decision reaction time are referred to as a decision side distance. As to recommended that decision side distance be provided at interchanges or intersection location where unusual or unexpected maneuvers are required. Change in the cross section such as the lane drops and addition toll plazas and intense demand areas where there is a substantial visual noise from the competing information. The decision side distance or a particular excessive stopping side distance are required at the intersection or as well as in that particular location where there are a high number of the vehicular demand are available. So, as to recommended that particular side distance for a particular highway or the class of the highway like the national highway, state highway, but in that particular location or the particular vicinity, there are a greater distance of the side clearance or the safe stopping side distance are required, like the intersection, because there are high number of merging and diverging lanes are available. There are the different maneuvers are occur at instantaneously. So the driver needs a particular kind of distance or particular kind of the facility for providing a stopping distance at that particular or without any collision. So the decision side distance is found by using the equation, replacing the standard equation B is equal to 1278.9 plus 377.4 is equal to 1656.33. So it is kind suggests that in the highway stretch there are not more than this kind of the stopping side distance are required, but at the intersection, providing this amount of the stopping side distance are required to just avoid the collision of a different vehicles at that particular location. Other side distance application, in addition to the safe stopping side distance and decision side distance, ASTO also set criteria for the passing side distance on the two lane rural highway, intersection side distance for the various control options. So this kind of particular decision side distance are available that reaction times, the design speeds, and the different equation that what kind of the distance are given. Like if the design speed is 30 mile per hour, so the assumed manual time or reaction time is 2.5 seconds. So from the equation or from the different class of the highway, the 219 meters feet are required for the proper maneuver of the vehicle. So this is kind of a table which are given by the ASTO on the basis of the recommendation of any new highway construction. There are another type, two different types of the side distance are also carry forward, like the passing side distance on the two lane rural highway and intersection side distance for the manual control point. So in the highway engineering, we were discussing the side distance at intersection and different two-lane side distance, or if there are particular one road available which allows a two direction of the vehicular movement. So there are kind of a two lane side distance are required, which are also given by the ESCO. Okay, so so here we conclude that the physical characteristics which are available or which are going to taken into account taken into account while constructing a highway. So there are the two main characteristics, like the road user characteristic and second is the vehicular characteristic. So in the road user characteristic, there are the two different methodologies or two different phenomena are included, like the psychological factors and the physiological factors. And in the vehicular characteristic, there are the braking characteristic, design speed, design beacon, safe stopping side distance, and the side distance at intersection, and another kind of safety side distance are to be included. So here we conclude our first chapter of the introduction of the traffic engineering, as well as a basic introduction of the road user characteristic and the vehicular characteristic. So in the very next lecture, we will start our new chapter of the traffic volume count and what are the different methods which are available to take count of or take a vehicle count in the traffic studies. So see you in the next lecture, and we will start a new chapter in the very next lecture. Thank you.